For question 4bi, we have the equation sec 2 theta minus 15 equals to cosec 135 degrees in the interval of 0 to 360. Since on our calculator we only have sine, cos, tan, this sec or cosec isn't going to really help us because we can't calculate using these. So we need to change them into sine, cos, or tan. We know using our identities that sec theta equals to 1 over cos and cosec theta equals to 1 over sine. So we can rewrite this as 1 over cos 2 theta minus 15 equals to 1 over sine 135. By cross multiplying now, we can find out that cos 2 theta minus 15 equals to sine 135. Now, we know sine 135 is root 2 over 2, and cos 2 theta minus 15 equals to that. So now we have our equation, but usually what we would have is cos x or cos y equals to this, but now we have an expression inside here. To make life simpler for us, we can substitute y in. So you can say y equals to 2 theta minus 15. Let y equal to that. So now you have a normal equation. Cos y equals to root 2 over 2. You can use the inverse function on your calculator, cos minus 1 of root 2 over 2. And you'd be left with y equals to 45 degrees. What we need to take care of, however, is this 0 to 360. Our interval has now changed because we've made this substitution, or because we have this. This is only taking care of theta, but we need to take care of 2 theta minus 15. So what you would do is you'd have 2 theta minus 15 in the middle instead. And you do that to both sides. So on the left you would have minus 15. And on the right you would have 360 times by 2. And then minus 15. Which is 360 times by 2 minus 15. 705. That's our new interval. So we're going to be finding angles in between this region from minus 15 to 705. We already have 45. Now we need to find the rest. 45 corresponds to this angle on the cos diagram. If we draw out our cos diagram. Since our equation was cos y equals to root 2 over 2, this cos indicates that this cos and this being positive means that the regions we have to try and find is this region and this region, because these are the only regions where cos is positive, because this is all and this is cos. This is 45 degrees, as we know. To find this angle, you would merely do 360 degrees minus 45 degrees, which would give you 315 degrees. Now, because our region goes to 705, you'd go around again. So 45 degrees is here, so when you go around once again, you add 360. So 360 add 45 equals to 405 degrees. And when you add 360 to 315, you would be left with 675. Now you can't go around once more because that would exceed the limit of 705. And you can't go into the negative section because the least negative you can have is minus 45. So this is what we're left with. Now because of this expression we've set up, we can now use a substitution of 2 theta minus 15 equals to all of this. So now you would just simply rearrange and change all of these y's into theta. And when you would do that, you would get 30 degrees. So 45 plus 15 divided by 2, that's 30. 315 plus 15 divided by 2 is 165 degrees. 405 plus 15 divided by 2 gives you 210. 675 plus 15 divided by 2 gives you 345. And there you have it. That's your answers.